Hello, welcome. Thank you for joining me today. I'm Li-Ling Young. This presentation is for HVAC contractors. We'll talk about the benefits of reducing refrigerant leaks and some steps you can take to make that easier. This work was funded by the New York State Energy Research and Development Authority through their Next Generation HVAC initiative. And additional funding was provided by Efficiency Vermont and VEIC. This is what we'll be covering today. We'll start with the role of the technician in combating climate change. We'll put some context around where the biggest opportunity is to keep refrigerants from accelerating climate change. And we'll talk about new options for recovered refrigerants. And then we'll have a few sections on ways to bring leak type practices to your company. Greenhouse gases are mostly carbon dioxide, and the biggest source of carbon dioxide is burning fossil fuels. But there is more to the story. Some of the other greenhouse gases are emitted in much smaller quantities, but are still big contributors to climate problems. You've probably heard that cow burps are greenhouse gases. That's methane. Methane is emitted through other agricultural processes too, like waste management. And methane is emitted in the extraction and processing of oil, gas, and coal. That methane is not counted when we talk about the carbon dioxide attributed to fossil combustion. Nitrous oxide follows methane as the next most important greenhouse gas. And we're back to agriculture as the largest source of nitrous oxide in the form of inefficient use of nitrogen fertilizer. And finally, where you come in, fluorinated gases are the remaining greenhouse gas that represents an important piece of the emissions pie. Fluorinated gases, or F gases, include almost all our conventional refrigerants, including the ones you work with every day. On this chart, the big blue piece and the smaller green wedge is carbon dioxide. And carbon dioxide is far and away the biggest contributor to climate change. That's why policies at the local, state, and the national level are supporting the move away from burning fossil fuels and electrifying how we make heat. You're involved in that through installation of heat pumps. And you also own that little orange slice. The impact of fluorinated gases can be thought of as small, but it's on the leaderboard, and it's a slice we can do something about by doing quality work. There's no reason that refrigerants have to contribute to greenhouse gases. An air conditioner, a refrigerator, a heat pump, even a commercial refrigeration system can and should go the entire life of the equipment without releasing even 1 ounce of refrigerant. You can make that orange slice disappear, and that's more than any of us can do for any of these other slices. Between 1990 and 2022, emissions of fluorinated gases went up by more than 50%. The rise you see here is entirely due to CFCs and HFCs, which is the class of chemicals that R12, R22, and R410A belong to. And actually, emissions from HFCs has increased even more than what you see here, because reductions in other types of F gases is masking the full contribution of HFCs. So what happened between 1990 and now? Well, adoption of central air conditioning grew, and heat pumps started to be used for heating and water heating. The increase of F-gas emissions over time shows that HVAC and refrigeration industries are contributing more and more to the climate gases that we're trying to reduce. Changes we make to how we conduct our business can have a big impact on greenhouse gases. Some refrigerants are very potent greenhouse gases. That's why the AIM Act, which was adopted in 2020, put in place a phase down of refrigerants with a higher global warming potential. Newer refrigerants are not as harmful as older ones, but they're still powerful greenhouse gases. The refrigerants in the green bar are refrigerants that have only recently been permitted to be used in the US. You probably know these are the refrigerants you'll find in air conditioners and heat pumps starting in 2025. The refrigerants in blue are the future, ultra low global warming potential refrigerants. A few years ago, the EPA adopted a new policy known as SNAP. And the upshot for all of us is that new equipment cannot use the super potent greenhouse gases that you see at the top of the table. R12 and R22 had already been phased out. R410A is getting phased down. Now, you're installing more benign refrigerants than you were in 2024. So, is the problem solved? What the EPA has done means that we don't have to worry about HFC emissions anymore? Not entirely. For one, the refrigerants we install now are still contributing to climate change, but there's a refrigerant risk we haven't even talked about yet. Before we go there, let's look at the effect of the transition from R410A to the newer refrigerants R32 and R454B. In 2024, 30,000 heat pumps were installed in New York State and 13,000 heat pumps were installed in Vermont. At 4 pounds of refrigerant per heat pump, that's about 174,000 metric tons of carbon dioxide equivalent. The GWP of new heat pump installations is going down. So in the coming years, we'll see 40 to 50,000 heat pump installations per year between New York and Vermont. But with R32 and R454B, that's about 45,000 metric tons of carbon dioxide equivalent. So yes, the effect of the AIM Act is showing up in how we install heat pumps and the lower global warming potential of the equipment that we're installing. Now, let's look at what that means with one particular heat pump that's used for heating. A 1.5 ton heat pump has about 3 pounds of refrigerant. Depending on what type of refrigerant, that's going to be between 1,000 to 6,000 pounds of carbon dioxide equivalent. That same heat pump saves between 3,000 and 4,000 pounds of carbon dioxide per year, depending on the type of fuel that it's displacing. That's a combination of the fuel that isn't burned, plus the carbon emissions of the electricity that is consumed. The blue bars add up every year. That means every year you can not burn the fossil fuel that the heat pump is displacing. And of course, that's what's so great about heat pumps. They really do save carbon. But those red bars can erode the benefits if the refrigerant leaks out. And sometimes those red bars add up too if there's a refrigerant leak and it's not repaired and the system keeps getting refilled with refrigerant. But those red bars don't have to erode the benefits of the blue bars. As long as the system doesn't leak and the refrigerant is recovered at the end of life, you get all the benefits of years of blue bars and none of the downside of the red bars. My company did a study of all the HVAC in commercial buildings in New York State. The bottom line is there's around 95 million metric tons of carbon dioxide equivalent in all that refrigerant. We didn't look at other things like single-family residential HVAC or commercial refrigeration. So even this large number only represents a part of what's out there right now. In the coming years, the number of heat pumps installed in New York and Vermont, as I just showed, is going to be between 40 and 50,000 heat pumps a year. The climate impact of those new installations is that teeny bar on the right, and it hardly even registers at all in the face of the carbon dioxide equivalent of the refrigerants that have already been installed and are out there now. We have to do something about that tall blue bar on the left, while at the same time building new leak-tight systems. We don't want the new systems to be a liability in the future. The transition to lower GWP refrigerants is not going to save us. The most important work in limiting the climate impact of refrigerants is repairing leaks in existing systems and recovering legacy refrigerants. Leak-tight new installations is going to make sure we don't have the same urgency about R454B and R32 that we now have about R22 and R410A. Now I'm going to switch to talking about refrigerant recovery. And I'm going to start that out by just a few reminders from Section 608. One, there is no part of Section 608 that allows venting of HFCs. A de minimis release does not mean venting is okay. There's no venting that could be counted as de minimis. Recovered refrigerant. If you recover refrigerant, it's okay to reuse it in equipment that's owned by the same customer where you recovered the refrigerant. But if you do so, whatever happened to that refrigerant and that equipment before you recovered the refrigerant, now you own it. If the refrigerant is not in good condition, that's now going to impact the equipment that it goes into. So at a minimum, run that refrigerant through 2 filter dryers. And finally, reclaimed refrigerant makes refrigerant that is at least as pure as virgin refrigerant. We know it's a hassle to recover refrigerant. Here are some things that we're aware of that are a challenge, and if there's anything that we've missed, I definitely want to hear about it. One, you need an empty cylinder or one that has the same refrigerant in it as what you're recovering right now. Because if you blend refrigerants, they have no value. And if you introduce air into your cylinder when you're recovering refrigerant, it reduces the value of the refrigerant. You need the right equipment. So that could include a scale, recovery machine, and recovery hoses. It takes a long time to recover refrigerant. You have to have storage for the partially filled cylinders. You need somehow to get those full cylinders back to a reclaimer. And I know that some people are still paying to dispose of recovered refrigerant. So what have I missed? You tell me. If there's something else that is difficult about recovering refrigerant, we want to know about it. There are some programs that are trying to address the challenges of recovering refrigerant. And that includes always making sure that you have an appropriate cylinder to recover refrigerant, easy return of the refrigerant, and making sure that you never have to pay to return refrigerant to a reclaimer. The program that I'm most familiar with is Hudson Technologies program. To get involved there, you just set up an account online. When you have refrigerant that is ready to go back to the reclaimer, you order a pickup online. They'll send a truck out to your facility. If the quality of the refrigerant is high enough when they test it, they will pay you for the market value of that refrigerant, and they'll send you a replacement cylinder for the cylinder you sent to them. So here's some ways that you can make your company more friendly to recovering and reclaiming refrigerant. First thing would be to stock up on recovery cylinders. At any job, you could have to recover refrigerant. And so all your work trucks need to have a recovery cylinder ready, and you need to have cylinders that are appropriate to any kind of refrigerant that you might find at your job sites. So probably that means more than one recovery cylinder in each truck. Make sure your company has the right equipment. Hoses, filter dryers, a scale, and recovery machines. The best recovery machines are really expensive, and that's because they work really fast. Is it worth it to buy the most expensive one? I think that if you have the right hoses and you don't do a lot of recovery, maybe you don't need to buy the most expensive recovery machine. Train your techs. Your technicians are not going to know the best way to recover refrigerants unless you train them. The top thing would be focus on company culture because it's going to benefit the company in more ways than just avoiding refrigerant emissions. When it comes to judgment calls, leadership really counts for a lot. So talk about it and make sure your technicians know why you always recover and you don't tolerate venting. There are ways to speed up recovery, so train even your seasoned technicians. The right hoses make a big difference in how fast the recovery goes. Train on the best configuration of hoses, pressure gauges, and what all. I'm trying to make this fast and easy, and at the same time, protect the quality of the recovered refrigerant. And finally, there are things you can do in hot and cold weather to speed up recovery. And some of them require extra tools, but some of them are just knowing HVAC equipment. It's outside the scope of this presentation to train on fast recovery configurations, but there's great content from Appion and AC Service Tech that you can get on YouTube that you can use to train your technicians. We'll return to some of this when we talk about tools in a couple of minutes. There is probably some additional record keeping to do in organizing and making your recovered refrigerant accessible for reclaimers. If you don't already have an account with a reclaimer, get your account set up. And especially if you're still paying to return your refrigerants, this is a much better way to go. It's not necessarily the case that you have to recover your own. Especially in big projects, hiring a contractor specifically for the recovery is common, but it's possible that some of these recovery contractors also do recovery at smaller systems. So if it doesn't seem worth it for you to set up your shop and train your technicians to do recovery, call around to the recovery contractors and see if you can get a contract recovery for small residential or whatever kind of systems you work on. And then finally, something to think about. In this age of refrigerant transitions, recovered refrigerants have a market value if they're clean enough. And you may want to credit back the payment that you get on the recovered refrigerant to the customer. It just makes the whole transaction more transparent and emphasizes the importance of recovering refrigerants. And now we're going to shift from refrigerant recovery to new installations. If you want to make a leak-tight system, there's really no special sauce. Everything we know about keeping water and debris out of the line set, making connections, pressure testing, and evacuating, all that makes both a long-lasting system and a leak-free system. The flare connection is where the rubber meets the refrigerant leak road. Cut the pipe perfectly, deburr the pipe perfectly, form the flare perfectly, tighten the flare duct perfectly. So we'll return to this when we talk about tools. Generally, brazed joints are reliably leak-free. Always flow nitrogen when brazing so that oxidation doesn't occur inside the pipe. Use a self-fluxing 15% silver brazing rod and no soldering. That leaves flux trapped in the refrigerant line. Leak testing at installation is required before introducing refrigerant into the lines. Use leak detection fluid at the joints. It's also a good idea to check for leaks whenever you service a system for whatever reason. When you're doing your visual inspection, suspect a leak if you see oil residue. We'll return to this when we talk about tools, but you really need to know how to use your leak detector. Once you think you know where there's a leak, use leak detection fluid to pinpoint the exact location. A leaking flare cannot be fixed by tightening the nut, and that's why it's so important to get it at the right torque at the beginning. If you have a leaking flare, cut out the flare and reform it. Anytime you attach gauges to a line set, some refrigerant will be lost. And even worse, you risk introducing moisture and debris into the refrigerant. Don't attach gauges to the system unless you know that only measuring the refrigerant pressure is going to solve the problem. The alternative is non-invasive testing. It starts with a thorough inspection of the air side and electrical. A visual inspection includes looking at the filters, the blower wheel, the condenser fan blade, electrical, the refrigerant connections, the condensate line, the thermostat. Listen to the system run. Once you know all the air and electrical processes are good, measure the temperature of the refrigerant at key locations, and that will tell you everything you need to know. There's a lot of math behind non-invasive testing, but fortunately, there are apps that work with connected tools to instantly give you answers based on temperature measurements. Using the apps overcomes the problem of an inexperienced technician that doesn't troubleshoot well or making a math mistake. It's a lot faster than any other troubleshooting method. There are tools that will help make leak-tight systems and that will minimize the loss of refrigerant during service. Low-loss fittings keep refrigerant in the hose when the hose is disconnected from the service port, and that's especially important on the liquid line. Stranded refrigerant can be reintroduced into the system on the suction side, but make sure the hoses were purged of air before filling with refrigerant so you don't introduce non-compressibles back into the system. Low-loss fittings can be standalone devices that are screwed onto your hoses, or some hoses come with low-loss fittings attached to them. Digital gauges. The most important thing about digital gauges is they're really accurate. If you're pulling a vacuum with your analog manifold gauge set, you don't know anything about how deep your vacuum is. But there are also some actual refrigerant leak prevention benefits of these gauges as well. The micron gauge or vacuum gauge can help you detect small leaks, and most importantly, it can show whether the vacuum loss you see is due to moisture in the system or a leak. And the pressure gauge releases much less refrigerant from the system than a manifold gauge set, if you have to measure pressure at all. Don't use a manifold gauge set for measuring system pressure. There are just too many places in a gauge set that could leak, and the length of hose bleeds refrigerant out of the system. When you have to use hoses, like for recovery, it's best to use a hose with as small an interior volume as possible. That keeps the refrigerant loss to a minimum. But there's also a big benefit to large diameter hoses, both for recovery and evacuation. A large hose makes the process go faster. And I think that's really important because one of the things that pushes technicians to take shortcuts is slow moving processes. If it's taking half an hour to reach a deep vacuum on a new system, some technicians are tempted to get it to 800 microns, watch it for a minute, and then call it good. And that is not the way to make a leak-free, long-lasting system. Deep vacuum and a vacuum decay test is best practice. So how do you make it easy to do a deep vacuum and proper decay test? A large hose, 3/4 of an inch for a vacuum, remove the Schrader valve, and a communicating digital micron gauge with an app. Most residential systems could reach a deep vacuum in about 2 minutes with that setup, and the app will tell you in a few seconds whether you pass the vacuum decay test. So, large vacuum-rated hoses for evacuation. Recovery hoses should also be large, but here there's a compromise, so we don't end up with a large volume of stranded refrigerant. A short recovery hose between the recovery machine and the recovery cylinder keeps the hose volume low, and a 3/8" recovery hose makes sure the recovery goes fast. Easy, fast recovery avoids the temptation to vent refrigerant. A 1 or 2 foot 3/8" recovery hose to the tank, any length 3/8" recovery hose from the equipment to the recovery machine. And finally, charging hoses don't need to be large diameter, but they should be dedicated for charging, and they should be pressure rated. I very rarely see any attention paid to deburring tools. Actually, sometimes I see them referred to as reamers, which sounds rough, like a rough process on the pipe. But the flare is a critical piece of the leak-tight system. Making a perfect flare starts with a perfect tube, perfectly round, perfect length, perfect angle, perfect thickness. Scratching up the inside of the tube end damages the material that makes your flare. You can deburr your tube with the stick style or the barrel style, but do it gently. You're not trying to thin the edge of the tube. You're trying to remove the little flange of copper that gets pushed in by your cutter. It's not a lot of material. If you use the stick style, replace your blade periodically. What I'm showing here is the single fluke countersink deburring tool. And I like these because the curve of the barrel fills the inside of the tube and keeps the tool centered. And the action of the handle minimizes the force you can put on the cutter. The bottom line is deburring is a precision process. Keep your tools sharp and know what you're doing. It doesn't take muscle. The next step in making a perfect flare is forming the flare. This is a powered flaring tool that I'm showing. The clamp has a stop that ensures the tube depth is correct, and an eccentric or off-center cone rolls around the inside of the tube to stretch it out and make the correct flare angle. There are simpler tools that can do a good job making a flare. Know your tool. Always use a stop and a gauge to ensure your flare is the right size. This is a flare gauge. Inside each hole is a little tiny lip. So if the flare fits in the hole and lands on the lip, the flare is the right size. But if the flare drops through the hole, it's too small. So check all of your flares with the flare gauge. And then finally, a perfect flare is tightened to the specification of the manufacturer of the flare nut. It can vary a lot over different size tubing, so tightening by feel is absurd. If you think you're doing a good job, but you're not using a torque wrench, well, you're not doing a good job. Once the refrigerant piping is complete, check for leaks. Both an electronic leak detector and leak detection fluid are essential tools of the trade. Yes, lots of techs swear by dish soap as a leak detection fluid, but some dish soaps are corrosive, and non-corrosive fluid specifically formulated for leak detection on copper is best practice. Make sure you're familiar with how to use your electronic leak detector. Does it need calibration? What gases will give a false positive? What refrigerants does it detect? How often do the sensors need to be replaced? Does it require periodic cleaning? And what's going to damage its accuracy? There are ultrasonic leak detectors that make it possible to hear a leak. Like leak detection fluid, they can pinpoint a leak. And unfortunately, there's a big learning curve with that kind of leak detector. We've talked about some ways you can build leak-tight work into your business. This section puts that into the context of refrigerant management, the whole cycle of a piece of equipment. At several key points in the life of a heat pump, there are opportunities to minimize the risk of a refrigerant leak. Design for smaller charge. Having a smaller charge in the system means that any catastrophic leaks are limited by that small charge size. The way to serve a larger space with a smaller charge size is to use multiple single zone systems. For instance, a one-to-one ductless system in the living room and another one-to-one ductless system in the master bedroom. Use a ducted heat pump to serve adjacent spaces. For instance, a single ducted heat pump can serve bedrooms that are close to each other. Or use a monoblock system. Monoblock systems have all the refrigerant in the outdoor unit and require no refrigerant connections to be made on site. The only monoblock systems I'm aware of are air-to-water heat pumps. And in contrast to all that, what I'm showing in the photo here, multi-zone systems often have a large refrigerant charge because of the larger heat pump size, and you can see all this line set needs to be filled with refrigerant. In a system like that, if there's a system leak, you could lose all that refrigerant in one go. Multi-zone heat pumps also have a lot of connection points, which increases the number of places a refrigerant leak could develop. Some refrigerants are much less damaging, and some refrigerants are so low in their global warming potential that they don't even get recovered. Right now, pretty much all you can choose from is R32 and R454B. But soon, codes will catch up with the natural refrigerants, and we'll start to see HVAC with super low global warming potential. Even now, I can think of a couple of heat pumps that use R744. When you have a chance to choose a more benign refrigerant, do it. It's one more thing you can do to minimize the impact of refrigerant leaks. Your customers might even appreciate the option. Set high quality standards in your business. Train your staff and make sure every one of them is using the best tools. And then finally, at the end of life, recover every ounce of refrigerant. If we do nothing to reduce the leak rate and increase the recovery rate, all of the high GWP refrigerants out there now will be released to the atmosphere. You can recall in my previous slide that tall blue bar representing all of those highly potent greenhouse gases. Only leak repair and refrigerant recovery is going to prevent that from contributing to climate change. You're the industry that can do that. I want to wrap up by talking about the customer's role in refrigerant management. If they expect leak-tight work, it's better for the climate and helps contractors prioritize eliminating refrigerant leaks. So tell your customers refrigerants are potent greenhouse gases. They might appreciate that you're being honest about that. Tell your customers you specialize in making leak-free systems. It's not normal for HVAC to leak refrigerant. Make sure your customers know refrigerant is expensive. Leak-tight work will save them money. If you decommission their old system, consider crediting the value of the recovered refrigerant to them. Thanks very much. I welcome your comments.